This is a Sec 4 Additional Maths Prelim School paper. First part, we have to find the expression for fx in descending power of x. Notice that there are already two linear factors given, -2 and this 3, which it gives us x plus 2 and x minus 3. So when we write it out, we have to use remainder theorem. So we have to show that -2 is a factor. Now when fx can be written as a factor with a multiplied to a quotient and a remainder, since there's no remainder because it's a root, so we can say that x plus 2 is a factor. Since -2 is a solution to the equation here. Similarly, since 3 can solve this equation, we'll just simply put in x equals to 3 here. So following the remainder theorem, this will be x minus 3 as a factor of fx. Because if you substitute 3, this factor will be 0, and when the factor applies to 0, regardless of the quotient, this entire term will be 0 with no remainder 0, and this will solve the equation given. We also notice that fx has a factor which is quadratic. So we can simply write fx in terms of the two linear factor x plus 2 and x minus 3 together with the quadratic factor. Before we do any expansion, we have to check that the highest power of x is this term, 4x power 4. Now notice that if we expand this out to give the highest power of x, this will only give us 2x power 4. X times x squared times 2x squared, 2x power 4. So 2x power 4 and 4x power 4, a difference in the factor of 2, so we just need to multiply by 2 in front. And expansion, of first two brackets of the linear factors will give us this quadratic factor together with the last quadratic factor, and further expansion will give us this expression for fx. Part 2, we have to find the remainder when fx is divided by 2x plus 1. So using the remainder theorem, if we treat 2x plus 1 as a factor, there should be no remainder. So remainder theorem states that if we would like to find out the remainder when fx is divided by 2x plus 1, we can use 2x plus 1 as the divisor. So the quotient form will be multiplied to the divisor, giving us a remainder. So in order to find the remainder, we have to make this factor a 0. So solving this to be 0, we need to find out the value of x to substitute, which will give us minus half. So simply for part 2, the remainder will just be substituting minus half, x has minus half into the function. And this will give us negative 10.5. Part 3 asks us to explain why that the polynomial fx has exactly 2 real roots. So we look back at the expression for the fx. And the 2 real roots would represent this equation such that we can factorize it completely to give us this. Now solving this equation, we know that we can simply take each of the factor and equate to 0. Now we can clearly see that we can have 2 linear roots here. Which is exactly the meaning when they say 2 real roots. Now if there are only 2 real roots, it would mean that this quadratic factor over here would have no roots at all. So in order to prove that there's no solution, we have to take out the discriminant to check. So discriminant of this expression notice we are not solving anything here. We are just finding the discriminant, which is the property of this expression. So it will be b squared minus 4ac, which is b squared 3 squared minus 4a c. Since the discriminant is less than 0, we can say that this quadratic equation gives us no real roots.